Hello and welcome back to CST 2120. So in this lecture, I'm going to introduce Node.js. So I'm going to start with an introduction to Node.js, explain what it is and what it does. Then I'm going to talk about how you can install and get it running. Then I'm going to explain how you can debug the JavaScript code that you write that is running on Node.js. Then we'll talk about a very important sort of aspect of Node.js, which is how to manage third-party libraries, which is called modules. We do this using the Node Package Manager. And finally, I'm going to explain how you can create your own modules, which makes it easier to write reusable code. Okay, so let's just, before we get into the details, let's understand what it is. Yeah, so far in coursework 1, you've used JavaScript in the browser, and that's how JavaScript started out. It was a, scripting language that ran within the browser and did useful things, changing the website dynamically. So running Gmail or something, there's a whole bunch of JavaScript running in the browser that's, fetching all your emails and dealing with all the kind of complicated graphics that go on, in the browser, yeah? So the idea when it's running in the browser is that this is called dynamic HTML, that JavaScript's changing the contents of the website in response to user actions, yeah? Like slideshows, animation, in your case, loading data from local storage, yeah? So what in essence is happening here is that the browser is executing JavaScript and that JavaScript is making the page change. So Node.js is a sort of adaptation of JavaScript that enables JavaScript to run without a browser, yeah? And so what they did is they took the JavaScript engine out of Chrome and then turned it into a console application, so that now you can run JavaScript just by typing node and then your JavaScript file, and it will execute just like a program in Java, C++, or whatever, yeah? And the nice thing about this, obviously we've lost the browser, but we've gained a great deal, yeah? What we've gained is that we can do loads of different things with JavaScript running on Node.js that we couldn't do if we just stuck to JavaScript running in the browser. So, it opens up a space of writing web servers in Node. We can do like data processing Node, machine learning, robotics, anything that you can do with a console application, like Python or something like that, we can now do in JavaScript as well. Now in the browser, JavaScript's an event-driven runs in an event-driven way, yeah? So instead of just having a sort of single thread that just or one or many threads are sort of churning away doing stuff, the execution of the JavaScript is driven by actions from the user. I click on something in the web page and it triggers a function in JavaScript that does something useful, in response to that interaction, yeah? So we create listeners or handlers that are triggered when events happen in the browser. And this has led to a sort of very efficient way of executing JavaScript code. This kind of event-driven way of executing it, yeah? And so Node.js, they haven't sort of completely rewritten the execution engine for JavaScript. All they've done is kind of put it in a console format, and that makes it, since it's still event-driven, that makes it relatively easy to build scalable, high-performance applications. You can still run multiple threads and do all this kind of stuff, but the sort of out-of-the-box Node is very similar to the version of to the JavaScript runtime engine within Chrome or Edge or similar browsers. So just to understand this, sometimes it helps to compare with other programming languages. So C++ and C, for example, are compiled down to machine code or assembly, which is basically executed directly by the CPU, yeah? So there's no sort of intermediate sort of piece of software that's required to run a C++ program on your computer. On the other hand, Java isn't compiled down to assembler or machine code. It's compiled down to bytecode, which is kind of similar, but that bytecode isn't directly executed by the CPU. It's executed by the Java virtual machine, which in turn is being executed but run on the CPU, yeah? PHP, if you know PHP, is executed by a server, so we need something like Apache to execute PHP scripts. And then JavaScript is typically executed either within the browser environment by the JavaScript runtime engine, or by a separate program, and Node.js is the only one I'm aware of, but there may be other ones, yeah? So I really like Node.js, I have to say. It took me a while to kind of come across it, but when I did, I'm a fan, right? I mean, now I write my research code in JavaScript, some of which is in Node.js, some of which is in kind of browser JavaScript, yeah? So one of the advantages of Node.js is that you have the same programming language on the client and server. Yeah. So if you've got a team of developers working on back-end, front-end, you don't have to have one of them that, know PHP and another bunch of them know JavaScript, one for the front, one for the back, and one for the front. Instead, you can just have a single team of JavaScript developers who can work on the, fluidly move between the front and the back-end functionality. Yeah. We can, have a framework. I think some frameworks like React will work across browser as well as on the server side. As I said, this event-driven architecture makes Node very efficient. It's a high-performance language despite being scripted, so we can build quite high-performance servers with it, yeah? We can build third-party, there are loads and loads, as I'll come to later, of third-party modules for Node.js. So if you've got a particular problem, like, I don't know, machine learning, or you've got a problem with reading a spreadsheet, or you want to build a server, or, whatever it is, there's a massive ecosystem of modules for Node.js that can be used to solve different kinds of problems in a really easy way. Yeah? And I'll come to that a little bit later. And personally, I find JavaScript a very nice programming language. Yeah, it's really easy to write. You do get funny errors sometimes that take a little while to unpack, which is why with my research code at least I use TypeScript, which is kind of like JavaScript but has types added on top, so you make less silly mistakes with it. Yeah. And JavaScript, has a slightly dodgy reputation, but it's evolved a great deal over the last 10, 15 years. And the modern version of JavaScript is pretty nice to work with, I have to say. And it's pretty easy to build fairly large applications on it, yeah? So VS Code, for example, is written in TypeScript, which, as I said, is basically a version of JavaScript, yeah? And by running JavaScript on Node, we can then, as I said before, we can open up lots of other applications of JavaScript. We can write web scrapers, web testers, robotics, build JavaScript applications that monitor our home and all this kind of stuff. Yeah. So hopefully I've convinced you there's some merit to this at least. And so now I'm going to talk about how we can actually get it running on our computer. Yeah. Now, if you've got your own laptop or desktop, the easiest way to use Node.js by far is just download and install the latest version. So the latest stable version I recommend, not one of the more bleeding edge releases, whatever they're called, release candidates or whatever. You want the sort of stable version with long-term support because that's the one that's going to have been tested the most. You should download it. You have an installer. It'll add node and npm to the path, or you can do this manually later. I'm going to mention the path a couple of times. Should have probably put a slide on it, but the path is hard-coded in the operating system, and when the operating system needs to run a program, for example, if I type node in PowerShell, the operating system will look on the path in all the folder locations listed on the path to try and find that program. And if it can't find that program, it'll generate an error message saying can't find a program with that name. Yeah. So when you're installing programs, the installer will typically add the place where the program's been installed to the path so that you can launch it from the terminal. Yeah, if that doesn't happen, we can help you with it in the labs, or but I'll show you how to manually add it to the path for running it from a portable USB stick here. Yeah, because as usual, I'm trying to work with these laboratory machines which are pretty locked down and not so brilliant. I'm supplying you with a portable Node.js, and I'll show you how to use that when we come to it a little later. Yeah. So what you have to do is download the portable version from the course website, put it on a USB stick if you're working on the lab machines, the easiest way to do it, and then just add it to the path. And once it's on the path, and this is just a manual thing, it'll disappear when you close the terminal, but you can change the path dynamically, and if you add that location of Node to the path, then you can then run Node within like VS Code or something similar, yeah? So if you want to use the portable version, if you look in the portable software for Windows section of the course website, there's a link to it there. You can just download it. And then first thing to do is test, right? See if there's a version of Node already installed, type node --version. If that command's not recognized, then you need to add the Node directory where Node exists to the path. Find where it is, open up the shell. Probably this is going to be the shell inside Visual Studio Code. I don't recommend just trying to use VS Code or WebStorm, one of these IDEs. And then you type, then you can edit the path. So the path in Windows is available as env path, and then you can just basically put this at the beginning of env path, and then it'll find it straight away. Yeah, we'd add it at the end, but it's actually easier at the beginning, at least of this demo. Yeah, and then you can then type node version, and if it is correctly installed, you should be able to just type. This will return something sensible. It won't say command not found. Yeah, and I'll show you how that works. Yeah. So once we've installed Node, then we can then write just ordinary JavaScript, yeah, and we can run that JavaScript using Node. Now, there's limitations in the sense that all the browser stuff, the document object model, we can import that stuff into Node, but it's not available by default because we're not working within the browser environment, yeah? But but the standard, vanilla, ordinary JavaScript, just create a script, write your JavaScript, and run it with Node by typing node hello world.js. So it's the same kind of procedure with, Python or Java, same idea, yeah? We have the program that executes it, and then the script, and type on the command line, and it should just run, yeah? Now, this is a little bit abstract, so let's show you how it works. Yeah, and I'm just going to restart Visual Studio Code, just to make sure that we haven't got it on the path already, yeah? So let's just do clear. Okay, so I think, now if I type something that doesn't exist on the path, just to show you what it looks like, say noce or whatever, doesn't exist, then you'll get this kind of error here, the term noce is not recognized as blah, blah, blah. That means that noce, it doesn't exist, right? It's not on the path, yeah? Now, if you want to see what your path is, you can do echo env path. Sorry, I'm typing across the microphone here. Okay, and then that there is the list of folder locations where Windows will look when you type in the name of a particular program you want to run, yeah? As you can see here, actually Node is on the path, yeah? If I type node --version, then we're getting version here 18.140. But I'll just show you how to add, a portable version to the path as well, because obviously, I've already got it installed. It's my machine. It's easy, yeah? So what I've done is I've copied the portable version onto a USB stick. And so you can see here, David Gamez, and then there's a folder here, Node, whatever that name is. So that is the path that I want. This is the sort of folder location that I want to add to the path, yeah? So what I have to do within the terminal that I want to run Node is I can then do env path, and then equals, and then I can paste in that location in quotation marks, and then I don't think I need the bin directory, and then add that. Oh, and then I need the semicolon. If I don't put the semicolon in, it'll combine it with the other folder. The path entries are separated by a semicolon. And then I'll add in the original env path, yeah? So if this works, it should be version 20 of Node, because that's the version I've got in the USB stick there, yeah? Okay. So now if I echo env path again, you'll see at the beginning, if it works correctly, here we've got JNode. So that's the first place the operating system will look when I type in Node, yeah? So with a bit of luck, these demos don't always work. Type Node version, and here you go, we've got version 20 now, because that's the version that's on the USB stick, yeah? And if I go, and this is local to that particular terminal, because if I type Node version here, then it's version 18. It's the one that's actually on the the one that's set within the operating system. And you can access that in Windows by just typing, pull up here and type environment variables, and you'll find, the ability to set the paths and stuff. But we can help you with that in the lab if you need it, yeah? Okay, so I've got Node, my Node work, correctly set here. So now I can actually create a JavaScript program and run it with Node, yeah? So the classic is obviously just an ordinary kind of hello world, right? I'd give it the JavaScript extension, may or may not, because then otherwise you get all the syntax highlighting wrong in VS Code. And then we can just do a simple thing, console log, hello world, alerts won't work anymore, hello world. And there we go. There's our very basic JavaScript program there, yeah? Just trying to save that. So now, to run this program, we type node, and then the name of the program, which is hello world in this case, yeah? And it's executed it, it's logged out all the logging, there's nothing else, it's a very simple program, obviously, and then it's output hello world. So that's our very basic Node JavaScript application. So, yep, done that. Now you can use anything you like really to write JavaScript and then just execute it on the command line using Node. But as with most programming languages, it's generally easier to use an IDE integrated development environment to do the work for you. Yeah. So I really like Visual Studio Code. I use it for most kind of front-end web development and even a bit of back-end web development. It's written in JavaScript. Lots of professionals use it. You're not going to go wrong using Visual Studio Code. But I have found, you know, that WebStorm, which is a commercial offering, is just a bit better and easier to use. So again, with my own kind of academic stuff, I kind of use WebStorm to develop JavaScript or TypeScript rather than Visual Studio Code. I'd be perfectly happy if WebStorm didn't exist, but since it does exist, I tend to use it, yeah? Now, you can also use WebStorm. All you have to do is register, create a student account on the JetBrains, you know, webpage. And then once you've created an account with them, you must use your student email address. Then they'll give you like a year's, you know, ability to, as long as you're a student, you can have the ability to use WebStorm for free, yeah, and all the other JetBrains products, yeah. So the full version of IntelliJ and all the rest of it. And there's some very nice pieces of software made by JetBrains, yeah. So what you do is you register, you get an account, and then when you install WebStorm, you basically log into the IDE using that account details, and then that will launch enable to use WebStorm on your local machine. Yeah, but the disadvantage is obviously that when you stop being a student, you won't have access to it anymore unless you pay for it, and then you'll probably end up using Visual Studio Code after that. So yeah, gains and losses. Yeah. So that's WebStorm. I'll show you how to do a bit of debugging on that later. Okay, so I've shown you Hello World with Visual Studio Code. And WebStorm's mostly the same, right? You kind of have the sort of, you know, the folder structure there. You press on the magic green button and it launches, and I'll show you some debugging with WebStorm later. Yeah, so somewhat unnecessary demo, I feel there. Okay. So now we're at the stage, I hope, of being able to run JavaScript applications on Node, either in WebStorm or Visual Studio Code. And I want to talk about debugging these applications, yeah? Now, a lot of people, when they're starting development, tend to use console log or the equivalent system out print line in Java, whatever the equivalent is, cout in C++. Yeah. So so to try and understand what your code is doing and where it's going wrong, people will often put in lots of logging information, and then that logging information will, you know, enable them to, in theory, figure out why there's a seg fault in C++ or why the Java application's just crashed. Yeah. And some logging output is always extremely useful, right? Particularly if, you know, if you're doing kind of complex applications where you want to output, you know, specific things about that application. And there's a number of third-party loggers. I'll introduce one of them to you now. That kind of quite helpful for, you know, controlling the logs that are output and seeing the errors. And obviously, if your application is running on a server, you know, there's no way you can actually attach a debugger to it. But so, you know, logging output's again very useful for tracking that your server's running correctly and identifying errors when they occur, yeah? So there's nothing, in theory, wrong with using console log, system out print line, or, you know, custom loggers and all of that. That's all good. But when you're building applications locally and you're testing applications locally, they're going to go wrong. And in that situation, using console log is often an inappropriate way to kind of figure out what's going wrong with the code, yeah? It's usually much quicker to use a debugger, attach a debugger to the program that you're running, and that lets you pause at a certain breakpoint. You can then see the values of all the variables without using console log or anything similar. You can then step through the code line by line. You can go into a function, go out of a function. You can just essentially run the program really, really slowly and have full access to what's going on inside the program, which is an incredibly powerful tool. And you can do this in like 2 clicks instead of writing all those console outs and then deleting all those console logs later, yeah? So as I'll show you, it's really worth learning how to use the debugger properly, yeah? So in the browser, because we're running the JavaScript in the browser, you know, like Chrome and similar browsers have developer tools in which you can run debuggers and step through functions and all this kind of stuff, do exactly the standard stuff you need to do with debugging, yeah? And that's built into the browser, and it's very helpful for debugging code in the browser, yeah? But when we're running code, JavaScript running on Node, you have to use the debug tools provided by the IDE. There's probably some kind of command line thing you do, but I'm just using IDEs for this because they're much easier, yeah? Okay. So WebStorm is a built-in debugger. You basically add the breakpoints. The breakpoints where the execution of the program will pause, yeah? So for debugging, you always need to say where you want to stop in the code, and then the program will stop at that, load up the variables, and let you step through and do all the stuff you want to do, yeah? So once you've added the breakpoints, if you don't have breakpoints, debugging won't do anything, but once you've added a breakpoint, click on the debug symbol, and then that'll enable you to, it'll run the code and stop at the breakpoint and let you do all the cool stuff that you can do with debuggers, yeah? VS Code has a run debug option on the sidebar. I haven't got much experience with this because I tend to use WebStorm, as I said. I'm not certain this will work if Node is not on the path, but it's certainly worth a go, and it's certainly worth using if you're just running this on a machine where Node's installed, yeah? The other option with VS Code is you can set this flag called auto attach, and this will mean that all programs that have a breakpoint will be automatically launched in the browser. So auto attach means the debugger will automatically attach to a program that has a breakpoint in it, yeah? It's a bit fiddly to set up. You have to sort of do Control-Shift-P, which opens up the options. You find the auto-attach option, you set it towards attach, restart VS Code, add the breakpoints, run the code in terminal, and then it should launch automatically. You can look at this list of stuff later by pausing the video, but I'll show you how to do it now anyway, yeah? So I'm going to start with WebStorm, and then we'll do the same. I'll show you how to do a similar thing with VS Code, yeah? So let me just talk you through the program I'm debugging, or it won't make a lot of sense to you. Yeah? So I've basically got a fruit array here, array of names, basically. And then what I've got here is a function that capitalizes it. Yeah. Now, any of you experienced developers will look at this and say, oh my God, you know, this is absolutely, this is ridiculous. He could have written this in 3 lines, and he'd be completely right. But the reason I've written it in so many lines is to show you the debugger in action and show you how a debugger can help you to fix some really simple errors. So what I've done, I actually wrote this program quite quickly, and I made a couple of really silly errors, and I'll show you how we could fix these silly errors very easily, or identify them at least, by using the debugger, yeah? So what it does is it, gets the first character in the string, and then it turns it into uppercase, and then it gets the rest of the string by doing a substring starting from the second character. And then it builds the capitalized word, pushes into a new array, and returns array. So the idea is that this will basically return an array. It'll take in an array of strings and return an array of capitalized strings. That's what we're trying to do here. And then this little thing here just basically outputs all of the new array that's been capitalized. Obviously, I should have checked for the types of the actually words had a length and though they were strings and all this kind of thing. But it's a demo, yeah, so not a perfect piece of code, okay? So let's suppose I want to debug this. Well, let's run it first, okay, just to show you what it gives you. Yeah? So obviously in WebStorm, you just click on, the run. And it's kind of weird, right? This all looks kind of vaguely plausible stuff, right? But what it's given us here is the output, this bit here, is just giving us banan, right? So obviously it hasn't worked. And now we're going to use a debugger to get it to see what's wrong and fix that, yeah? So we put a breakpoint in here just by clicking in the code in the editor. And instead of clicking on the triangle, we click on the sort of little buggy symbol here. And then that will run the program, and it'll pause, as you've seen, at the point at which we put the breakpoint in, yeah? And here, if we look here, we can see all of the components of our application, yeah, all of the variables. Yeah, this become clearer later, yeah? Now, what we can do is we can step over things, we can step into functions, we can step out of functions. I think we can run to cursor. I've never played around with run to cursor. And if we want to just forget about all this debugging stuff, we can click on the green button, it'll resume the program, and then it'll go on to the next breakpoint, yeah? But we're just going to show the basic usage here, yeah? So here I want to step into capitalize, so I'm going to use that, yeah? And see here, instantly we've jumped to the beginning of the capitalize function. And if we look here, we've got the word array. This is the argument here that's been passed into the capitalize function. We've got, you can see here all the words are lowercase, yeah? Now let's try and figure out what's going wrong with this, yeah? So I'm going to step over that. Now we've got this for loop here, okay? So let's just go through here. So remember, so now we can see all the variables, right? The 3 variables in this particular block are first char, word remainder, and capitalized word. So if we step over this line, then first char gets set to B. So we know that the first word's banana, right? So word here is in this loop here. That's set to banana. First char's B. That's correct. Things are looking good so far, yeah? And then we want to turn that to uppercase. And so first char has now been turned to upper B. This is looking good so far. And now we're trying to get the word remainder. That's the rest of the word minus the first character. Now, if we look here, the word remainder here is anan. So almost certainly the problem is that we've set word.length probably should be, it must be, it's always fiddly with arrays, right? But this should probably be word.length, not word.length -1, because it's chopped the last A off the letter, yeah? So the word remainder is wrong, and that's why we're getting this anan or banan rather than banana. Yeah. So let's keep going. Now, capitalized word, that makes sense, right? So capitalized word here is banan, when we realize now the error we've made here. So now we're going to store that in the new word array. That looks good to me. Aha, but now we've hit our problem, right? We're now returning the new word array with it from at the bottom of the for loop instead of outside the for loop, yeah? And that's why we've now, so obviously that's why we're only getting a single banan, because we're returning it kind of straight away. And if we kind of step out of the function, then we're getting fruit banan. So if we wanted to fix this, we'd change that to that, and we'd move that down, and probably forgotten the shortcut, there we go. And save it, and then we run it again, and then here we've magically fixed it, fruit, banana, da 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 da. I'll put it back because it's sort of quite a useful example. So you can see that by stepping through this function one line by line and looking at the variables, it's far easier than running some kind of console log at each point and trying to figure out what went wrong. I mean, this is a very simple example, but if we were trying to do something that had, 1,000 lines of code for your, then it's going to start getting really messy and complicated, and it's much easier to use a debugger to figure out what's going on. It's not always perfect. If you're talking multi-threaded application, it can be tricky debugging it. If you're talking callbacks and all this kind of stuff, or promises, it can also be a little tricky. But with straight, simple code, not necessarily simple in terms of length and complexity, but simple in terms of not asynchronous code in some way, debuggers are just brilliant tools, yeah? Okay, so let's try and do the same thing here with in VS Code, yeah? Now, there's a couple of ways we can do this, yeah? One way we can do this is using this run and debug sort of menu item, should we say, on the left, yeah? So if I just run and debug it normally, you can see here there's no breakpoints attached because it's a different IDE. So if we run and debug it, we're getting the same error here, banan, yeah? But we can do the same thing here. We can add the breakpoints in here, click on run and debug, and then we can then step into, same sort of stuff, right? Step into here, we can step over the lines, we can step out of the function, rerun the function, and so on and so forth, yeah? And obviously identify the same sort of errors. And let's just run and debug it again, actually, to show you the, let's step into that, and let's step over a couple. And then we should be able to see, I think, we've got local variables here. So within this block, we've got word, which is undefined. And if we step over that, we're getting word becomes, where it's gone, block, word banana, right? And then, and then you can see the contents of the array being passed. So it's exactly the same thing as with WebStorm, yeah? And then we can stop it, or keep running it to completion kind of thing, and do exactly the same stuff as we did before. I'm not certain this is going to run if Node's not installed. So I'll just show you another way to do this, which is Control-Shift-P, and then we can type in auto attach, and then we click on debug auto attach, and we can set that to always, yeah? So at the moment we're just using this thing here which launches the debug console. But if we go back to our ordinary terminal, I think we're still in Node 20. Yep, still in Node 20. Now what we can do is we've set auto attach on. I think we need to restart it because I tried this before and it didn't work. So we restarted it, yeah. Probably need to I'm not going to bother resetting. I think now the version is 18 again, but we, obviously could reset the path if it didn't exist on the path. But now I've got auto attach on, I can just run my application with a breakpoint, and it will, in theory, not 100% sure because I'm not a heavy user of this, but Node, what do we got? Debug demo. There we go, right? So it's automatically attached to debugger because it's got a breakpoint in it, and then I can just do the same stuff here, yeah? And this is all running within the terminal environment, so I'm guessing, but not 100% certain, that this will work just fine with the sort of locally installed, with Node being set to the path manually in the way I did it, yeah? Okay, so I think that's all I want to show you in terms of debuggers. Let's just check, yeah? Yep, I think I've kind of covered that, yeah? Okay, so, and obviously debuggers, they're not unique to Node or JavaScript. If you're using Java, the same applies. Yeah, if you want to figure out quick ways to solve your code problems in Java, use a debugger, don't use system out println, yeah? Now, next bit I want to cover with Node is the Node package manager, yeah? So Node.js is it's a really big sort of thing in the sense that there's many useful third-party libraries. Yeah. So you're going to need, so if you've got a particular problem, something you want to do with JavaScript, there's a very good chance that there's a Node.js module out there already that will solve the problem. Yeah, there's a huge ecosystem of developers contributing to Node. It's really popular. And so there's a large number of third-party libraries for Node. Yeah. You're going to need to use at least a couple of these for coursework 2. You're going to need Express and the MongoDB connector, and you may find yourself using a few more as well. Yeah. And it's true again of any programming language. Yeah, I teach Maven in the 3rd year, which is like a package management system for Java. Yeah, so if you want to use third-party libraries for web scraping or something, you can just install them and configure them with Maven. But in Node, returning to JavaScript, we use the Node package manager to do that. Yeah, it's really quite easy to use. Yeah, so if you're interested in what's available for Node, have a look at the npm.js sort of website. And you can just search for different packages, and it'll tell you, if I just search logging, I've got, almost 8,000 packages. Most of that, some of the search will be junk, but some of that search will return, really useful stuff that you can use for an extra logging tool with extra functionality if you want. Yeah. So once you've installed Node, then the npm should also be on the path. But again, if you get stuck with that, ask us in the labs. And so first thing, if we start a new project, we need to type npm init, yeah, because unless the folder you're working in has a file called package.json, then you won't be able to install and use libraries, yeah, third-party modules, yeah. So you type npm init, it asks you a load of questions. You can fill them in if you like. You can always change your answers later by editing package.json. And once it's finished, you end up with this package.json, which has the configuration information, and then you can install and use your libraries. So let's do a quick demo of that. I'm going to stick to VS Code for the moment. I'm not going to bother reinstalling Node 20 because I've got Node on the path anyway. Let's just clear that. Okay, so where are we at? I'm going to go to demo here. So if you look in demo, there's nothing inside that folder at the moment. Yeah, so Node package manager is not going to work yet. Yeah, so what I need to do is type npm init, and it's going to got the debugger attached. Anyway, doesn't really matter. So we just basically press return, work through all this stuff. I could answer all these questions, but I'm not going to bother. And then get all this, and then type yes if I really want to, and then it's created a file. If you look now in demo, I've got this file called package.json, and then there's certain things I might want to change in that, and also be able to see in order to support modules, for example, which we'll come to later, and then I can install my libraries into this folder. Yeah. So to install the third-party libraries is pretty easy. We just type npm install. There's some parameters we can use, but that's the basic usage, or npm-i, I think it is, and then type the module name. So if I wanted to install a module called logging, I'm not going to demo that because I found it wasn't that useful, but then I type npm install logging, or if I want to install Express, it's npm install Express. Yeah, and all the names are going to be lowercase. Yeah. Now, what this will do is it'll create a local installation of the logging module. So what npm will do is it'll create a folder called node modules, node_modules, inside your folder, and it'll copy all the files that are needed for that module inside node modules. Yeah. Now, please, when you submit your, coursework 2, parts 2 and 3, please do not submit node modules. Yeah. It's a big file. It can be like, 7 megs or something like that. And that's going to interfere with your ability to fit in the video and all the other bits and bobs for your submission, yeah? And the first thing I do when I download your submissions is delete all the node modules folders, yeah? So it's completely pointless submitting your node modules. If I really want to run your application, I will very quickly install them with npm, which would take me like less than 30 seconds, yeah? I probably won't because of the database dependencies and stuff. So, I really don't need the node modules, and I will always delete it when you submit it. So it's really just going to make your life harder, and it's going to make my life harder. So just please don't do it, yeah? Now, there is an option. You can use the -g flag to install libraries globally, or modules globally. So with TypeScript, you need to install it globally so you can use it on the command line. With other stuff, I just did, and for coursework 2, just stick to local installation. Yeah, it's just easier. And sometimes the global installation doesn't always work sort of neatly, yeah? So stick to local installation, and then you'll be fine. Okay. Okay, so let's talk about installing module. Okay, let's do that. So, okay. So I've got my demo here. I'm going to stick to this, yeah? And where's my packet module demo? So I've got my logging example. I'm just going to turn my, put a folder in here called test.js or something, yeah. So here I've got some code. Oh, I typed it wrong. Call it test.js, yeah. So inside my demo folder now, I have this file called test.js. And this, in theory, I'm going to use this logging library called Pinot. It'll import the library from Pinot. We'll talk about imports in a second. And then it will use the library and then, and then output some stuff with the library, yeah. So if I do, so here we've got test.js. So if I just do node test.js, you're going to get this error, yeah. You're going to get this. Oh, well, that's a separate thing. Let's do a slightly different version of this. Const Pinot. I'll explain what this means in a second. I just want to show you an error. Yeah, equals require Pinot. Yeah. Okay. I'll do it this way. Yeah. So I get the right error. Yeah. Okay. So, oops. Okay. So we're getting an error here, and the error here, which you'll see a lot, and just to understand what that error is, that's why I've done this. Deliberately created it here, is it says it cannot find the module Pinot. So I just want to check something. Yeah, just about visible. Okay, so it says it cannot find the module Pinot. And the reason it can't find the module Pinot is that I haven't installed the module Pinot in this folder here. Yeah. So to install it, it's very easy. I just type npm install. I think it's a slightly shorter version of this. So Pinot is like a logging library for JavaScript here, running on Node. Yeah. Just debugger things slightly annoying, but never mind. Okay. So I've run this, it's run successfully. You can see added 23 packages and all that. You can ignore the details there. But now you can see that Node modules is really full. Yeah, so this is why I want you to submit it, because it's full of Pinot, probably uses other third-party libraries, which internally uses other third-party libraries. So, it can all get rather complicated, yeah? So now, so I originally remember I had that error message, module, I had cannot find module Pinot. Now I've installed it, and now I can run that application. And it says, here we get, this is the Pinot output there. Yeah, so my program's run successfully. Yeah. So it's really just npm init, and that creates the package JSON. And I think the dependencies go in package JSON as well. Yeah, and then once everything's installed, I can then run and use third-party modules. Yeah. Now, as you sort of got a glimpse of there, you can't just putting the modules in the right folder is a start. But to actually use them, we need to link to them in our code, yeah? And when you're looking at Node tutorials, you see a lot of examples where they use require, yeah? This is the old syntax for linking to libraries in Node, yeah? But what they've done, since about Node version 16, is they've updated it to bring it into line with kind of modern JavaScript. And so now all the modern examples and modern usage of bringing libraries in for Node is to use the import statement instead of require, yeah? So I'll show you both, yeah? So this is the one I just wrote, right? So here we've got the require statement. So the first thing is the name has to match one of the modules installed. It shouldn't have any / or anything before it, yeah? So require, basically, the Pinot module will export something by default, and require means it'll import into this code, and then that'll be copied into here. So in this case, Pinot is a function, okay? So when I call that function, Pinot, that's been imported from the Pinot library, Pinot module, it will then return the logger, and then I can then use that logger in my code, like logger info or whatever, yeah? Okay, so it's basically returning something, could be a class, could be a function, could be a variable, here, and then when I'm using that in my code, in this case to create a logger, and that logger I can then use for lots of different things, yeah? So that's the old code, and you'll see a lot of Node examples that use the old code. The more modern method of linking to libraries is using the import statement, which is supported from Node version 16. Yeah, it's very similar to JavaScript imports in the browser. So in JavaScript, you can have a script type module, and if you have a script type module, you can then export things from one module, and I'll show you how to do that in a bit, and import into another module. Yeah, and so now they brought the Node JavaScript in line with the browser JavaScript, and that makes it much easier for everyone. Yeah, and if any of you are familiar with TypeScript, that also uses a similar import syntax. Yeah, but to make import work, I have to set the type of the application to module in package JSON. Yeah, so here's my package JSON, and I've set type module, and you remember that error I got before the other error? That's because I hadn't set that there. Yeah, and so basically this similar syntax. Here we have Pinot here is the name of the module, and import Pinot, if I haven't got curly braces, what will happen here is Pinot will be the default export from the Pinot module. So you can specify specific exports, which I'll show you in a bit, or you can just have a default export, which I'm not going to show you how to do, but with modules there typically is one. So here I'm importing the default export, and in this case it's a function. When I call that function, it creates a logger that I can actually use. Yeah. So I'll show you the export stuff. Okay, so first thing I have to do in package.json is change. This is all JSON, remember, so it's got to be type, and this is module. Okay, so I'll save that, and then where am I at? Okay, and this is test.js, isn't it? And then here, instead of the require stuff, I can just import Pinot from Pinot, right? It's very easy syntax. And then this should, in theory, run. Okay, yeah. And so here we've got, in fact, I'm going to detach. If you get sick of this debugging output, you can just disable it. And then I'm just going to restart VS Code because all this debugging stuff is slightly doing my head in here. Okay, so now I got rid of the auto attaching. So now it'll only debug if I want it to, yeah. Oh, right, I'm in the wrong folder here, yeah. So let's do cd demo, and then run the thing, and then you can see here more clearly, that's the output from Pinot, yeah. So I've imported the Pinot, and then now I can it'll return a logger, this Pinot function, and then I can use it in my code, yeah. So that's third-party modules, which we'll use a lot. You'll come back to that when I'm talking about Node with Express and Node with MongoDB, yeah. Final thing I want to cover in this lecture is how to create your own modules. Yeah, we talk about third-party modules. That's fantastic and useful, but often in your code you want to create blobs of code that are reusable and it can be used in different ways. Yeah, and in the browser we don't have to worry too much about that because we can just create multiple script tags that link to different bits of scripts, and then the browser will basically copy and paste those scripts into the main execution environment, and then they'll all be able to work together. When we're working with Node, it's better to think in a slightly more kind of object-oriented way, not necessarily writing classes, which you can in Node, but more in terms of having files that contain pieces of functionality and then exporting pieces of functionality into other files in order to be able to use them, yeah? And how that's described in Node is in terms of this word called modules. So it's really easy to create your own modules in Node. Just make sure that type is set to module in package.json, which I already mentioned earlier. Then if you've got some things that you want to export, we just type export before the variables, functions, and classes we want to export. And then we can then import them into the files where we want to use them, yeah? Now the difference between the third-party modules handled with NPM and the ones that you create is that you have to start your own module names with the / and they have to be .end with JS or it won't work. And the other change is that unless you have a default export, which I'm not going to cover here, you have to use curly brackets and name the imports that you want to bring into the file where you want to use them, yeah? That's these curly braces, yeah? So we need to make sure type module is set, and then we can export functions or classes or variables, whatever we want, just by putting export before them, and that turns my module.js into a module. And then in the import side, we just use the import keyword, and then we say what we want to import. Remember, we exported say hello, so we want to import say hello. So you can see here why we maybe want to use defaults, because if I don't know that this thing's called say hello, I won't be able to import it by name. But anyway, since I know the name, that's fine. So here I'm saying I want to import say hello, and I use the curly braces here. And then here, remember I've got the / before and the JS, so I'm saying where it is. Otherwise, if you don't use the / it will look in the Node modules instead of looking in your file system, yeah? And then once I've imported say hello, I can then call it in my code, yeah? So let's very quickly sort of try and code this up kind of thing, yeah? So let's stick to my demo thing. I'll call this, sorry, I don't want to put in a Node module, that's short. Okay, so let me, oh yeah, that's all right. Okay, so let's call this my stuff. I don't know, I'm not feeling very clever. And we'll use it, and then we'll change test to use that. Yeah. Okay. So let's right. So my stuff here, terrible name, I know. We'll export a couple of things. Yeah. So export function. Stick to say hello, just 'cause it's easy. And name, and then console log hello name. Yeah, pretty easy, nothing very clever. So I can export a function, right? But let's just for fun, right? Let's export const pi or something equals 3.1415. Might have some constants I might want to export as well, for example. Yeah. Okay, so I'm exporting a function here, and I'm exporting a sort of constant variable. Yeah. So, and then here in test, I can then import this stuff, right? So remember, you need to use the curly braces to name what I'm importing. So I can import pi, and I can import say hello, and it'll probably autocomplete with a bit of luck from, maybe not, /my stuff. You need to put the JS, I think that's pretty much essential. So we import, and then we can then use these things in our code in just an ordinary way, right? Console log, whatever, pi, okay, and then we can do say hello, you know, Tony or something like that. Yep, okay. So let's just run it, make sure it works before I keep knocking this light off. Okay, let's just run it, make sure it's worked. I think I've saved everything. Yep. Console is not a function. What? Oh, console.log. Sorry. Don't make silly errors. Okay. And here we go, right? So we've exported these modules, the pi and the hello function. Now, if I didn't export them, right, suppose I didn't export say hello. That's now private and local within the file. It's going to give me some error about, you know, requested module does not provide exports name say hello, yeah? So obviously you always need to export it in order to successfully import it, yeah? Okay, well, I think that's pretty clear. And so I recommend when you're building larger applications, you know, modularize them, create modules that do different things. I mean, what I usually do is create a class that does something and then import that class into other, and then export that class and import it into other files, yeah? So Node.js lets you run JavaScript programs without a browser. It's fantastic. I love JavaScript. Really good programming language, particularly if you use TypeScript as well. You should really learn how to use Debugger with Node because it will make your life a great deal easier and quicker than all those kind of console logs, and that's true of all programming languages. When you want to use third-party libraries or modules, use the Node Package Manager. For Express and Mongo, you're going to need to use that. And you also should, as a general rule, organize your code into reusable modules. And that's it.